Not all problems are quadratic, but we can kind of rewrite them so that they are quadratic. And one way that we go about doing that is by using a substitution method. And a common substitution method doesn't happen all the time, but it happens often enough. Is if we take that middle term, x to the 1/3, and we let u equal that middle term. Then, if we square both sides, u squared would then equal x to the 2/3. So instead of using x to the 1/3, we'll use u, and instead of using x to the 2/3, we'll use u squared. And we'll just rewrite the equation using the variable u. So we'll end up with u squared. We're going to replace that instead of using x to the 2/3 minus 3u minus 4 is equal to 0. Now we do have a quadratic equation, and we can use the quadratic formula, or if it factors, we can go ahead and factor it. In this case, you're going to have u, and then you'll have 1 and 4 plus and minus. For the first factor, u would have to equal -1, and for the second factor, u would have to equal 4 in order for the equation on the expression on the left side to equal 0, u would have to equal -1 or 4. Now remember, we're not solving for u, we're solving for x. So we got to go back and we got to replace the u with the x expression. So instead of using u, we're going to replace that u with x to the 1/3, and that's going to equal -1. Well, if I'm solving for x, and I'm taking the third root of x, I'm going to go ahead and do the inverse of that, which is cubing both sides. I'm going to raise the left side to the third power, and I'm going to raise the right side to the third power. That's going to get rid of that 1/3 exponent. 1/3 times 3 is 1. So basically you're left with x to the first power is equal to -1 times -1 times -1, or -1. So that's one solution. And then the other solution would be x to the 1/3 is equal to 4. Again, I'm going to cube both sides of the equation, giving me x is equal to 4 times 4 times 4, which is 64. So the solution to this equation would be x is equal to -1 and 64.